Hi, welcome. This time I'm going to show you how to create a new database in Patran, and also how to import a Midsurface and analyze it using the software Nastran Patran. In this case, we are going to create our Midsurface sketch in SolidWorks because we only have the student's license for Nastran Patran, and in that license you cannot create a Midsurface. So we made the sketch in SolidWorks, and then we import that sketch to the software. Well, the first thing we want to do is create a new folder. The name is going to be Midsurface, and we're gonna add the program Patran. We're gonna copy the program, and also we're gonna add the file of the Midsurface that we model in SolidWorks. And now we're gonna start. So we open a program, and we are going to create our new database. So we click on file, then new, and we set our file name, which is going to be Midsurface, to avoid some troubles at the end with the names. And we select the folder we want to save all the information on. So we select desktop and then Midsurface, and we click OK. Well, the next step is to import our file. This is also a Parasolid XMT. So we select our file and we click apply. When the summary pops up, you only click OK. We're gonna run an entire full run model. This is at the end, so we ignore this. And this is our model. So now we are gonna associate all the edges. So we click on geometry, and then the object is in action. We select associate, and the object is going to be curve, and the method is a surface. Well, in curve list we select the vertical edges like this one, and in the surface list we select our face, this one, and we uncheck the auto execute and we click apply. Now we are going to repeat this process for all the remaining edges. So we erase the curve list selection and we do it again, and the same with the surface, which is surface night again. So we click apply, and then we go with the second face. We select the vertical edge and the surface, we click apply, then we go with the second one. No, this is surface 11. Okay, then we go again. We click apply, and Now the last one. Now it is ready. We have all the edges associated to the box of the Midsurface, and now we are going to create our mesh. So we are going to click on meshing, then create a mesh. The type is a surface, a quad 4, and we are going to change isomesh for paper. The surface list is our entire model. And we're gonna uncheck the automatic calculation, and the value is going to be 9. So we click apply, and now we get our Midsurface mesh. And so now we are going to verify our elements. So we click on verify. We change object for element, and the test is going to be boundaries. So we select the free edges and we click apply. And after that, we are going to make an equivalence. So we select in action, equivalence, then all, and tolerance scale. We click apply, and now we are gonna verify again all the elements in the boundaries. So we select verify, element and boundaries, and we check free edges again, and we click apply. Now we are ready to add the constraints. So we click on loads, BCS, we enter, we create a total load, and the type is element uniform, and we set the name, which is going to be total underscore load, and we want to make sure that the target element type is 2D, and we input the data, and we add a vector in edge load of 0, 100, and 0 again. We click OK, and now it's time to select the application region. We're going to select the icon edge, which is this one. It is already checked, and now we're going to click on the edge of any small hole, like this one here. This is the first one, the second one, the third one, and the fourth one in both phases. So we're gonna start, and we select the first one, we click add, and then we go with the second one, we click add again, and we do the same with all the holes in both phases. Then we go with the next phase. Okay, we start again. Okay, now it is ready. We click OK and apply. As you can see, there are our constraints with the blue letter. Now we are going to create a displacement nodal load. So we click on loads BC again, we are going to create a displacement nodal. So we select displacement. Where is displacement? Here, and nodal. And we set the name as fixed. Okay, we're gonna input the data. In this case, the translation vector is going to be 0, 0, 0, and the rotation vector is the same, 0, 0, 0. And we click OK, and we're gonna select now the application region. In this case, we select geometry entities. We click, and in this time we need to select this option, which is we're gonna select this option, which is curve or edge. So we select curve or edge icon, and we select the edge of any hole of the base. Sorry, here, this hole, and we do the same procedure as the small holes in the faces. So we select it and we click add, and then we go with the next ones. Okay, add, and where is the other one? Here. Add again, and okay, and apply. Now our constraints are created. Sorry. And the next step is create our material. So we go to properties. We are going to create an isotropic material. So we select isotropic, and the name is going to be aluminum. And we're gonna input the properties. In this case, the elastic modulus is going to be 10:6, and the Poisson ratio is 0.3. We click OK and apply. The next step is to create our solid. In this case, it's going to be a 2D shell solid. So we enter 2D in object, and in type we select the option shell. And now we're gonna set the name, which is gonna be 2D underscore shell. And we're gonna make sure that this is an homogeneous and standard formulation. We click on input properties, and now we select the material, which is the one that we created. So it is aluminum, and we click OK. Sorry, I forget that we need to add the thickness, which is gonna be 0.125.125, and we click OK and then apply. With all the constraints, now our model is ready to be analyzed. So we click on analysis. In this time, we're gonna run an entire model, and this run is going to be full. So we want to make sure that the job name is the one that we set at the beginning. In this case, is Midsurface. And now we click on subcases. We select default, and after that we click on output requests, and in the output requests box we select the second option, which is stress or one real one misses. We click OK, apply, and then apply again. Now our program is running. So when the black window goes out, we attach a result in an XDP file. So we select that option, which is this, in this case we make sure that our available job is Midsurface and the job name is Midsurface again. So after that we click on apply, and now we are ready to obtain our results. Well, under results we are going to create a deformation. In this case it's going to be displacement translational deformation result, and we click apply. Now here is our final result. As you can see, the green color is in this part of the Midsurface box. So this show that the most critical area is this one, the one that has the 4 holes. And well, this is all for our practice. Thank you for watching.